parallel computing techniques and his thoughts on the matter.
All right, so this slide introduces me. What's important is that I'm actually building tools for people to build tools with, and also known as programming language research. And from a programming language point of view, scripts are actually a very good very good way of dealing with the accidental complexity of making various tools work together. So gluing together applications to get things done. There's a reason that command line and these old scripting languages are still being taught today. Now, with the explosion of data and compute power necessary, it's inevitable that we're moving towards more distributed and parallel computations. So suddenly, the scripting techniques break down. The complexity that you get in those, let's say, traditional scripts just completely explodes in your face. So there have been a lot of initiatives to hide this complexity from the users, to encode all this extra compounded complexity. But you always indirectly pay the cost for that, even if you hide it away. So this is a grain of salt, by the way. How does it do? So let's look at trying to what's the actual essentials that the user needs to impart that you want to keep in the actual scripting approach. And actually, there's a big difference between a sequential and a parallel script. You don't just add a parallel for and call it a parallel script. So a parallel script is one where all operations ideally can work in any order. So you can run everything at the same time if you have enough resources. Now, of course, the world doesn't work that way. You need to have valid resources. You want to impose ordering constraints on your program so that you have a valid output. So you're starting from a different default. And there are many essential ways of ordering. I'm not going to go deeper into that, but it's not just file input and output. There are many other types of dependencies. So this is the philosophy of the recipes or parallel recipes approach. We just reuse the existing complex glue of scripting languages, and we focus on this complex coordination element. So we want the user to express these ordering dependencies, and then under the hood, we have a complex coordination language. So we use internal concurrent collections to do the actual parallelization and the scheduling and all the fancy parallelization techniques. So how does it actually look like? A simple hello world. What is the minimum amount of information that you want from the user? Of course, what do you want to run? So you need a command. This command is run when its input dependencies are met. When the command is executed successfully, it will satisfy its output dependencies. So this is very simple. This is 5 minutes explanation work. So how does that work in practice? We have a simple prototype, JSON format. Of course, this isn't final, to actually encode that information. And you can actually get very far in that. So in collaboration with some colleagues who work on pipelines, so I'm working with some of the LPRED people, developed the example best practices pipeline from Broad for exome sequencing. And this actually works pretty well. If you remove all the input and output dependencies and you make sure the order is okay, you get a sequential bash script. So this works. And actually this scales pretty well. So it scales across many computational nodes on a cluster very efficiently. And also, so this is the power of the concurrent collection, the recipes approach, is that you use transparently also all the parallelism on the node itself. So we also scale very well with multiple workers on a single node. You lose a little bit of parallel efficiency, but that's due to the nature of the actual pipeline. We have big cores, tasks, BWA and GTK that run for hours. So it's harder for the parallel scheduling to actually pick up and solve little imbalances in the pipeline. So what's next? Last 3 days were very productive. So shout out to the CodeFest organizers and the CodeFest people, especially Boscha, who helped me to integrate my work on recipes with CWL. So the idea is that we take the CWL workflow specification, and there were a lot of similarities, so this was actually pretty easy, and integrate it with the CWL core for tool specification, and then we can run this. This is almost finished, so a few days of extra work, and I can probably make a release of this. So to conclude, we have a very simple parallel scripting solution backed by a very powerful coordination system, so I can easily add extra parallel constructs. and we have CWL integration coming very soon. So it's on GitHub. Please try it out. Talk to me if you're interested in how this works.